Okay, we talked about how current flows, right, from positive to negative, and electron, which is negative by nature, will be from negative to positive. You must remember this, right? Then I also briefly introduced the difference between the alternating current and direct current, right? Direct current are basically like your batteries, right? They only allow current to flow in one specific direction only, right? Whereas alternating current, they will always flow in two directions, means to say it will go clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, and so on and so on. Yes, and that's why if you draw a graph here, you'll see that both the direct current one, it will always be in the positive region, whereas alternating current will just literally alternate between the positive and negative region, indicating that this is positive, this is negative, this is positive, negative, positive, negative, positive, negative, and so on. Okay. Okay. Then after that, we talked about the electromotive force, right, guys? I emphasize this once again that this part here is actually quite oftenly asked in your exam. They'll ask you how to define an electromotive force, which from the formula itself, you're going to remember that it's work done over charge, right? So you can literally bullshit your way through and say that electromotive force is the energy needed to drive 1 coulomb charge around the circuit. Very important, right? I'll teach you later on how to remember this formula. There's an easier way to remember this. And we also talked about potential difference, guys. Potential difference is basically just measuring the difference in potential between many multiple points. For example, if this was a 3-volt battery, right, this here will be 3 points and here will be 0. And this 3 will be consumed by this guy, left with 1, and this will be 0. That's why it measures the difference here and it measures the difference here. That's why they call it a potential difference. Right, important. But all of it is measured in voltage. Okay. Then after that, we stopped here last week, guys. We stopped here last week. And yeah, basically we're supposed to introduce you a little bit of Ohm's law today, guys. I'm gonna throw you into the exercises. Okay, now guys, pay attention. In terms of Ohm's law, right? Ohm's law is a very important formula. Ohm's law, guys. Ohm's law, right? Basically has a very general formula of V equals to IR. I think some of you guys may have learned this in school already. Some of you guys may have not. But Ohm's law is always talking about resistance, guys. And if you're talking about resistance, right, R will be equals to V over I. Some schools, they will teach you this V equals to IR, which is my personal favorite. Some schools, they will teach you R equals to V over I, which is literally the same thing in terms of algebra only, okay? So from here, you need to know that this is resistance, which is measured in ohms. It has an omega symbol here, right? This V is obviously volts, which is measured in volts, and I is obviously, once again, current, which is measured in amperes, guys. Now, from here, they also teach you that you are expected to know, the difference between an ohmic conductor and a non-ohmic conductor. Non-ohmic conductor, okay? So an example of an ohmic conductor is basically like copper wires, okay? Why do I say copper wires? Let's imagine today that I have a copper wire here. If let's say I supply 10 volts of voltage here, what's going to happen is, let's just say, right, I have 1 amperes of current flowing, right? But if I supply it with 20 volts, what's going to happen is I'll have 2 amperes of current flowing. If I supply it with 30 volts, then obviously my current is going to increase proportionally, okay? And because my current and voltage increases directly proportionally, right, I can draw a graph. I can draw a graph, a V versus I graph that looks something like this here. Okay, it will be a directly proportional graph, meaning to say at a certain voltage, it'll have a certain current. A higher voltage, it'll have a higher current. More high voltage, more high current. Okay. Now, I want you guys to all remember back into the year 10 classes, guys. I said that whenever we looked at graphs, right, we can always extract something from a component of the graph. Can anyone remind me what can I extract from this graph here based on what component of the graph?
Gradient.
Good, it's the gradient, right? And once again, if we look back about the gradients formula, gradient is change in y-axis over the change in x-axis, right? And from here, I know that in this scenario, the change in y-axis will be the change in voltage over the change in current, right? Which then, if I look at this thing here, oh, look, oh, this thing looks similar to this thing. It means to say that the gradient is supposed to represent the what?
Resistance.
Yeah, it's supposed to represent the resistance here, right? The gradient is supposed to represent the resistance. And if I have an ohmic conductor with a constant gradient, this simplifies and tells me that ohmic conductor generally has constant resistance, like your wiring, right? Your normal copper wire, no matter how much current or voltage you supply to it, the other part will always increase proportionally. For example, 10 volts, 1 ampere, 20 volts, 2 amperes, 30 volts, 3 amperes. So more voltage means to say more current. It will increase proportionally, thus indicating that a copper wire has constant resistance. Okay, so these are what we call ohmic conductors. The resistance is literally constant one. Okay, anyone has any questions before I move on to the next part? Good, 100% absorption rate. That's what I like. So next thing here is what is a non-ohmic conductor? A non-ohmic conductor, if an ohmic conductor has constant resistance, then obviously a non-ohmic conductor will have changing resistance lah. Oh wait, give me a minute. I've got a phone call. 1 minute. Bro, catch up. Do you know that I was I was talking on the phone and then your music just full blast and I had to quickly mute myself. Okay, anyways.
I hit a space bar. I didn't know it did that.
You did that on purpose. Right?
No,
I know you
it
did.
wasn't.
Okay, anyways, back to this. Guys, like I was saying, a non-ohmic conductor basically has thing that is non-constant resistance. For example, the most famous non-ohmic conductor is a very redundant technology, which is something we call the filament lamp. Anyone else still use a filament lamp at home right now? You all know what a filament light bulb is? Yeah, okay, but anyways, okay, let me just quickly whip up a nicer picture.
Don't people still use those things? Or do we use like LEDs now?
Yeah, everyone uses LED right now. Almost no one I know of uses filament lamps. No.
Dude, there's a filament lamp right above my head. I think.
No, it looks like a filament lamp only, but inside is LED already. Like
no.
Yeah, serious. Like you see this? It looks like a filament lamp, right? Where's the LED light? But anyways, let me find a
Nah, I don't believe you.
Okay, guys, look at this. Look at this here. Okay. Yeah. Okay, so let me tell you why this is a redundant technology. Okay, last time before LEDs and everything was invented, right? What they usually do, right? Obviously, the electricity goes in here and then it flows from here, right? The electrical current now flows from here all the way until this point here. Okay, this point here, you'll notice that at this point onwards, it's actually made of a different metal. It's a filament. What's filament metal? What filament?
Tungsten.
Sorry, it's a tungsten. Yes, I've heard a brain jam a bit. It's that this thing is
teaches the teacher.
Shut up. Okay, this here is what we call a tungsten metal. Okay, the working principles of this tungsten metal is that it generally has very high resistance. So when the current flows in here, right, the only way for it to actually generate light, right, is for the resistance to be high, which will cause the tungsten metal to increase in terms of temperature. The temperature will be so high that it starts glowing red. Then only will it like emit light energy outwards, So if you think about the energy process, right, it goes from electrical energy into heat energy first, then only it turns into light energy. In this process, how much energy is lost really? Because as we all know, heat will always be dissipated to the surrounding, right? So this caused the electricity to be really ineffective, right? So right now, what they do is, right, they no longer use these filament lamps. Instead, they use LED lights. Okay, these LED lights will skip one part of it. I mean, it's not supposed to look so changi, but it is that changi, right? All these LED lights they skip one process. They skip off the heat of this process here. So this thing is no longer here. They directly convert electrical energy into light energy, but of course, like when there is light, there will always be some byproduct of heat, right? So some heat is generated from the light energy, right? And then this actually minimizes a lot of electrical wastage, right? So when LEDs first came out, right, a lot of companies they did something like, oh, I'll help you swap out your whole house for LEDs, and you can see like a 30% reduction in your electricity bill, which was true. So a lot of people actually started selling a lot of LED lights, and that's how LED came to play here. Okay, so if you look back at here, right, this ohmic conductor, first and foremost, it has to allow current to flow until this part of the electrical copper wire. Then this next part here is the tungsten wire, where it will generate a lot of heat. Then the electricity will go up from here. Okay, and from here, what you have to understand is resistance is actually directly proportional to temperature. When you have a high resistance wire, it will generate a lot of heat in the wire, but the temperature will then again cause the resistance to increase again. And this becomes like a vicious cycle process that will continuously increase the temperature, increase the resistance, increase the temperature. That's why you can see the filament lamps, right? They will slowly glow red until its maximum brightness, right? Because the resistance in the tungsten wire itself is slowly increasing already. Okay, so whenever you see the word non-ohmic conductors, I want you guys to straight away think about this filament lamp, guys, which is a non-ohmic conductor. And because of that, if you were to draw a graph, if you draw a voltage versus time graph, voltage versus current graph, which way do you think it will tilt? Will it tilt this way, number one, or will it tilt this way, number two? Which one? Guys, anyone wants to take a wild guess? Number one or two, based on your information of mathematical. Which one is the one that has increasing resistance? Very good. It is number one. Excellent. Because if just now I've already mentioned that the gradient represents the resistance, an increasing gradient, as you can see here, indicates that it has an increasing resistance. Now I want to highlight this part here, which most of you guys copied. You know, in the notes, I made most of you guys copy the increasing resistance one as this one, right? In your exam, I want to highlight this. The graph will never be always just standard V versus I. Sometimes it could be I versus V here. Which then the students ask me, hey, if this is the scenario, think about it really logically, then it just reverses, right? You're supposed to point this way here. But there is an easy way to remember this, guys. I want you to know that if it is a non-ohmic conductor and you have already identified that it definitely has increasing resistance, based on the formula itself, right? If the resistance increase, it must have a it has to have higher increase in terms of voltage, right? Which is essentially what is happening here, okay? The graph must tilt towards the V-axis, okay? Whichever way the direction is. I want to emphasize this, this always comes out in exam, and a lot of assholes, right? They always, what they do is, they will just see that, oh, then they just say that the graph increase like this one, point upwards one, then they don't see this already, like, it's not there already. As long as they see a graph that increases like this, they circle the answer and then hope and pray that everything is correct already. Which then, of course,
Something I do.
yes, which then today I obviously cannot beat you because literally later on there will be a question to test you this. But next week when I do see some of you guys do it wrong, right, I'll beat you next week for sure. Okay, so nice. Yeah, I want you guys to add on one more thing here, guys. Constant resistance and increasing. I copy this down and then can you guys attempt the 3 questions at the bottom? You have 7 minutes to attempt it. Who's not here in my online class? I know Kai Xing is not here because she said that she'll be missing.
Rio Tan Cheng Rong.
Rio and who?
No, that's his full name. I just mentioned his legal government name.
Where is Rio? Rio is not here. Charles is not here. Who else? Tommy is here. Where's Natalie? Bloody hell, I said online class, they think no class, is it? guys want to see my little doggy?
Yes. Yes.
Show
Yes.
him, show him, show him.
Okay.
Dog.
You should do a floor drop
Dog.
test.
My tummy is grumbling. He's so cute, bro. Oh my god, I just want to eat him. Can he speak English?
No, this one speaks Brazilian.
Damn.
Aspen! Bloody hell!
Hey, hey.
Do the
We live, we love, we love.
anyone starts blasting music onto my Zoom again, I'll just mute you permanently.
You can do that.
Yeah, I think
Wait,
so.
wait, wait, don't try it on me. Don't try it on me. Thanks.
Hey guys, you done? Everyone done? I mean, anyone not done with this one yet? Okay, yeah. All right. Hey, let's go through the answers. The next part is the relatively more important part. Okay, so very straightforward. All these questions is just literally applying the formula. This is voltage and this is current. Right, you asked to find the resistance, which is VOI, right? Then it's literally 12 divided by 0.2. And you press that in your calculator, you'll get 60 ohms. Right, yeah. Okay, then after that, same thing for this one. And also, you're given the resistance, you're given the current is V equals to IR, which in this case here will be 2.5 volts. Very straightforward. And I ask you to find the resistance given this and this. COVID. All right. So it's literally R equals to VOI here again, which in this case will 12 divided by 0.5, which you'll get 24 ohms initially. And with the 24 ohms, they increase the voltage to this amount. So you're looking for the current, right? Which is V over R in this case here. It will be 15 divided by 24. And you press this in your calculator yourself and you'll find the current. Something, I can't remember how much it was, right? But press your calculator, 15 divided by 24. Okay, everyone? Should be quite straightforward. I don't assume anyone had difficulties doing this part here. Okay. Anyways, moving on to the next part here. This is the important part, right, guys? This next part here is the one that a lot of students actually cannot answer, guys. So you actually, if you can answer this, this will actually give you an edge over the rest of the students, and you will once again push yourself higher into the threshold. So please pay attention. Okay, now guys, in terms of the factors, factors affecting the resistance of a factor affecting the resistance of a wire, there are 4 main factors, but you only need to remember 2 of it only. The first factor is the length of the wire. The second factor is the cross-sectional area. Cross-sectional area of the wire. Third one is the temperature of the wire. And the final one is basically the resistivity of the wire. Okay. So how and each and every one of these factors going to affect the resistance of the wire? I want you guys to always imagine right, you know, if you want to remember how these things affect the resistance of wire, I want you to imagine them like pipelines first, okay? Let's imagine today I have a pipeline of this length, right? And another pipeline of this length here. And then I have the same amount of water. I have the same amount of water, let's just say like water flowing through here and here. Which one do you think the water will easily flow out of, guys? which one do you think the water can easily flow out of between these two pipelines? I'm sorry. The short one. Good. Water can easily flow out here because obviously, if you think about it in terms of a molecular level, these water molecules will have abrasion against the walls of the pipe, right? Which will cause them to have some friction. Obviously, if I have a shorter pipe, then it's easier to flow through here, whereas compared to this one here, the water has to go through so much abrasion here, like friction against the side of the pipeline, which means to say it's relatively harder to flow through here, right? Today, I want you to imagine this pipe is a wire, and instead of water, right, this is actually current, okay? So what's going to happen is it will be the same exact concept as well. Instead of water molecules, it will just be electrons having friction against the walls of the container. I mean, walls of the wire here, right? And because of this, I know for a fact that if I have a shorter length, the resistance in this wire will be what, higher or lower? This one will have higher or lower resistance compared to this one. Good. Someone answer me. It's not that hard of a question. The short one will have a higher or lower resistance.
Higher resistance.
Higher resistance.
Oh, I thought you meant like surface, like cross-sectional area, the shorter one will have.
What? Cross? Bro, I'm not even at this point yet. I'm literally at this point here right now only. What do you
I
mean?
don't know, I was looking at your drawings.
Nah. Yo, wait a minute. Does anyone not understand what I'm talking about here or not, first and foremost? I'm trying to show you that, catch up, especially you. I'm trying to show you that if you have a shorter wire, it will generally mean that it has a lower resistance because the electrons do not have to go through so much friction compared to a longer one, where it obviously has to go through much more friction and thus generate more resistance. Do you understand? It has nothing to do with cross-sectional area.
Oopsies.
Okay, so from here, I want you to remember this. It will be the exact same concept for a cross-sectional area as well. Today, if I have a wire of this cross-sectional area versus a same length wire with one that has a much larger cross-sectional area, which one do you think the current can easily flow through? Cash up, can you answer me this one?
Larger cross-section area.
Yeah, this one, the current can easily flow through here, right? So it means to say this one will have a higher or lower resistance.
Lower resistance.
Yes, very good. This one will have a lower resistance compared to this one, which has a higher resistance. So from here, first and foremost, I can make a relationship between them already, right? I know for a fact that the length is directly proportional to the resistance. Low length, then low resistance, right? But area, cross-sectional area is inverse, right? If I have a small area, my resistance is higher. They're inversely proportional. And if I have a high area, my resistance will be lower here. Okay, these two is what I'm trying to show you right now, which is the important part. Because of these two things, generally in your exam, they'll actually test your understanding based on this formula. Resistance is dependent on length over the cross-sectional area of the wire, which makes sense, right? Just now I said that higher length and higher resistance. If I have a higher cross-sectional area, then I'll have a lower resistance here. Anyone don't understand this part not first? This is very important, by the way. But don't worry, I'll give you guys lots of questions later. This part is very important. You must know this.
Sounds like Lady Gaga.
Okay. Okay, guys, everyone. Okay. Anyways, moving on to the next part. So from here, yeah, the other two factors are not so commonly asked. And when I say not so commonly asked, for some reason is in the what's it called, the syllabus, but I've never seen a question on it before. Okay, the next one is basically the temperature of a resistance, like I mentioned. They are just directly proportional and also a continuous vicious cycle. More temperature, more resistance, more temperature, more resistance, right? And the last one is the resistivity. Based on different materials, right? I'll have different resistivity. For example, I know for a fact that copper, maybe gold, okay, maybe gold, right, is a better conductor compared to copper, right? But we use copper for all our electrical wiring because it has a better conductivity to price ratio. Okay. Now, of course, the higher the gradient, such as tungsten, or even something known as constantan, like the higher the different materials are with the exact other same factors will generally have different resistivity, right? So these are the things you need to know. Anyone has any questions for this part here? Or have anything I've mentioned so far? Oh, suddenly there's one more student joining in. Who was the last one? Chris. This must be Charles. Hey, Charles, why do you join so late? You know how long class has already started?
Sorry.
Did you assume that there was no class today, by the way?
Yeah.
Very good. That's the one that doesn't read the question properly. Okay, guys, I want you guys to copy everything down from here, and at the side, I want you to write down the formula also, like the resistance is equals to length over area formula. And then, yeah, copy everything down.
Yo, bro, can you scroll down a little bit? Thanks, dude. Are the units for the cross-section resistance to centimeter square?
What? Say that again.
Like the units for the cross-section, the graph, is it resist ohms to centimeter square?
It could be anything. They don't specify usually in the question. It could be meter square, it could be cm square, it could be mm.
No, but it's like the ohms against the cross-section, right?
The what? The what? Say that again.
Resistance against cross-section, right?
Oh, yeah. It's going to be like resistance against cross section.
Okay. You have answered my question.
Okay, guys, everyone done copying? Anyone not done copying yet? Good, excellent. 0 responses. Okay, then final thing is we're going to learn about how the power and energy formula works in terms of electricity, guys. If you think back about the power formula, the general power formula is power equals to energy over time, right? Right, this was the general power formula, right? But in terms of electricity, guys, if you think about your TV or your fridge or your aircon, in order for these electrical devices, right, to have power, what must you supply into them for them to run? What are the 2 key components that you must supply to your electrical devices for it to run? Can anyone give me a wow guess? Voltage, good. The first one is that you must supply voltage to your electrical devices. What's the second thing? Very good. You must supply it with current as well. Okay, which makes sense, right? If you think about it, really logic and basic thinking will tell you that if I want to turn on my computer, I must have voltage and current flowing through it, right? Then it will power up the computer, right? Which is essentially what we have here also, guys. So from here, in terms of electricity, power is dependent on the voltage and the current. The more voltage and the more current you supply to it, then obviously the more power draw it requires. For example, your aircon will most probably be your most power hungry electrical device at home. That's why if you on a lot of aircons, usually your electrical bill will be relatively high. The second one is going to be your fridge. And then the third one will be your instant hot water. These 3 things generally I notice consumes a lot of electricity. Okay. Now power actually has 3 other formulas which you can slowly derive based on the Ohm's law formula of V equals to IR. Today, if guys pay attention to this, you need to know how to derive this. If today I know that voltage is equals to current times resistance, right? Can I put this thing into this thing here? Right. And if I put this into here, what I'm going to end up with, power equals to IR, since voltage equals to current times resistance, right? Times I, right? Which will give me my second formula. Power is equals to I square R. Right. My third formula is based on the Ohm's law formula as well, just that this time I make I the subject. Since I equals to V over R, right? And this is my I, right? This is I and this is also I, right? I'll substitute this into here this time, which gives me my third formula. Power equals to voltage times V over R, which is essentially going to give me P equals to V squared over R. Okay. Now, based on these 3 formulas, guys, depending on the situation, you're actually expected to use different power formulas. The most common example is like if I give you voltage and current, then obviously you have to use this formula to find power. If I give you current and resistance, then you have to use this one. If I give you voltage and resistance to find power, then obviously you have to use the third one here. You are not expected to remember these 2, right? But you are expected to remember this. You're supposed to remember this and derive both of these 2 here based on your Ohm's law formula. Anyone don't know what I'm talking about? Anyone wants me to repeat this? This is important. Good. 100%. Right. Then yeah. Can you guys just go ahead and copy this into the first box first? Let's copy everything from here into the first box first. Then we'll talk about electrical energy. Okay. Okay, everyone, done now. Everyone done with this part here? Next part. Guys, in terms of your electrical energy, guys, once again, you have to base it off the general formula. Since I know that power is equals to energy over time, right? Then from here, literally energy is equals to power times time, right? Based on algebra. And since just now we understood that P is equals to VI, all I need to do is substitute this into here, which will give me E equals to VIT. Okay, this means to say that the electrical energy is dependent on the voltage, current, and the time that you supply to it. And obviously, the more time you use your aircon, then obviously the more electrical energy is going to consume, and thus the higher the bill. Okay. Now, based on this E equals to VIT, you can actually relate this back into the electromotive force formula. Just now we said that electromotive force is work done over charge, right? If I make V the subject here, guys, if I make V the subject here, right, V will be equals to E over IT, right? And essentially, energy is going to be work done, right? Because work done is a form of energy, right? And since IT is equals to Q, then this is equals to Q here, guys. What I'm trying to show you is that you, based on this formula, which I find the students generally easily remember, you can actually derive it back into your electromotive force formula, which will help you bullshit your way through your definition, guys. So this is actually important. You need to know this. All right, copy this down into the next box. And for those who are done copying, you can start attempting the questions at the bottom already. Try to finish the ABCs before the class ends, guys, and then the rest of it will be homework. We'll discuss the answers on this paper next week. Next week, we'll continue on with a very important part of the electrical energy chapter, which is going to be the parallel and series circuits. So please make sure you did your homework here so that you have a better idea of how to attempt the next set next week. Alright, guys, if you're at least done with the first 3 questions, you're supposed to get a very big number here, which is 240 multiplied by 5 multiplied by 120. Because once again, I want to mention that time is measured in seconds. You should know this by now. And this one here is basically just P over P, which is 1500 divided by 240. I don't have a calculator. Press all of this into your calculator yourself. And this is the answer already for question number 3. Yeah, so it's not much to do here. Just do the 2 questions only. Yeah. Oh, good. That was a test. And the current, right? Calculate the resistance and the current. So your resistance, you have voltage, you have power. You're supposed to use the P equals to V squared over R formula. Your R is equals to V squared over P, which in this case here will be 240 squared divided by 1500. Good. That was a test. Cheated, you pass. And make sure you write your units, whatever your answers is. Okay, guys, and then the rest of all this here is basically just going to be your homework. Guys, you have 7 more minutes to ask me something before I end the class and let you guys go about with your Saturday holiday.
Yeah, do you like your new dog?
Like it, love it.
Oh, wow.
I've been teaching him some dumb tricks.
I think you should show us like
The tricks? Okay.
like show the tricks, you feel me?
Let me take a video later and I show you guys some tricks again. Send it to the group. And he burrito. I haven't taught him to burrito, but I've taught him to roll over, which is like the first step of burrito.
Can he slinky like the Toy Story dog? Can he like stretch?
No, but he can speak German.
What? Are you serious?
Yeah.
I don't believe you.
But
I'm already
he
watching a World War II documentary.
but he keeps saying this. He keeps saying hail, something like that. The second part is not so. It says hail, like that.
Might need to consider him dropping him off.
Yo, I think your dog is like, you know how there's a theory of how life works, and it's like you die and you get reincarnated as someone else, some other Hugo Quest dog. I think your dog was actually Hitler in the past life.
Maybe What? Hitler? Who's Hitler?
Oh, I mean,
Who the hell is Hugo Quast? Hugo Quast.
you don't want to know. I mean, you don't want to know.
Must be making fun of one of your friends again, assholes. Guys, I want you to attempt this all the way until this page as homework, and we'll discuss the answers next week. Okay, guys. Then I'm gonna end class here today. Please make sure you do your homework, guys, and I'll see you all next week back at our center.
Goodbye.
Goodbye. Enjoy your weekend.
Can you
boys.
bring your dog to Tuition Center next week?
No,
Or does the dog get COVID too?
no, it's not fully vaccinated yet, so I can only bring him out somewhere like December.
Hey, Gabriel, I think you should be anti-vax.
Yes, I will. All right. Bye.
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 Justin, you got a question, Justin?
Nah.
All right, see ya, man.
Bye bye.
Bye.